This video, I'm going to kind of quickly go through our notes for lesson 3.1, and this is our introduction to functions. So we're going to start by talking about what a relation is and what a function is. First, it might be helpful to kind of think about, we're going to be talking about coordinate values, and so by that we mean like if we have a coordinate plane here and I've got my x and y, and then we have some point out here. I'm just going to put a random point on here and say maybe this is -3, 2. That is a coordinate pair where I've got an x value of -3 and a y value of 2. So we're going to talk about these points and groups of points and entire graphs. And so this relationship we're going to be talking about is going to be comparing inputs to outputs and thinking about how those things are related to each other. So we talk about the inputs as being those x values, and then our outputs are the y values. And what a function is it's a special way to think about the way that these things are related, that for each input there is exactly one output. And so this will probably make more sense when we just start looking at examples. Kind of a simplified way to think about this might be is each x goes to only one y. Since x is our inputs and y is our outputs, each x goes to exactly one y value. So, for example, if we look at A, our inputs are our x values, so we have those listed here, and then the outputs are the y values. So if we notice this set of inputs, I just wrote those out, none of them repeat each other. Okay, so each of these x's is only going to one y value. It's okay that the y values are repeated. What would not be okay is if I have the same x value going to two different y values. Okay, so this one is an example of a function. As soon as we get over to B here, we see an example of what is not a function. Again, I've got the same x value. I've got this value of 4. So I've got an input of 4 and an output of 0. But I also have an input of 4 and an output of 3. And that is what we say is not a function. Moving on to a different look here, we've got a table. Again, the same thing. I've got my inputs. We notice we have duplicated inputs, so I've got input of 0 and an output of 5. Input of 0 and output of, input of 0, output of 5, input of 0 and an output of 6. So again, not a function because each input of 0 does not go to exactly one output. 0 goes to 5 and 0 goes to 6. Final example here, we made a little table. And again, I've got my each x value only goes to one y. We're also going to look at, start thinking about domain and range here. And the domain is the list of all input values, or in this case, x values. And the range is a list of all output values, y values. So if I look at this diagram here, the domain is again just all x values, 1, 2, 3, 4, and the range is a list of all y values. This would be a function. I have no repeated x values, so there's no way that a x could go to more than one y. Same thing over here, but now we have our domain as an interval, because if the domain is all x values, this is a line connecting it, so we have to think about all of the x values that are along this line as well. Remember, x is just left to right, but, so this has an x value of 1, And this has an x value of 2, so think about, we just draw this line down, that's 2. And then in here, we've got everything between 1 and 2 as well. And then this has an x value of 3, but we have everything in between there, and this x value of 4, and we have all x values in between. So when we think about domain, we really just think, okay, going from left to right, my lowest x value is a 1, my highest x value is a 4, and since I've covered everything in between, then my domain is all of those x values that are bigger than or equal to 1 and smaller than or equal to 4. Range is very similar, but now we're going up and down because this is a y value of 1. We're going all the way up to a y value of 3, and again, we've got everything in between covered as well. So the range is all of those y values greater than or equal to 1 and less than or equal to 3. When we have graphs like this, there is kind of a quick way to tell whether or not we have a function, and this is called the vertical line test. What this says is if a vertical line hits a graph 2 or more times, then that graph does not represent a function. So for example, our first one here, this is not a function. Again, if I can draw a vertical line anywhere and it hits twice, it is not a function. And obviously there's a lot of places here where I could draw a vertical line and it would hit the graph more than once. And this makes sense if we think about what this really means. These coordinates, right, this coordinate here and this coordinate here, they would have the same x value, right? Whatever this x value is, these 2 points would have the same x value but different y values. Okay, so that would be the same input x going to 2 different outputs y. So that's why it's not a function when it doesn't pass that vertical line test. And again down here, even if we don't have a continuous graph, but we have these points that have the same x value but different y's, still not a function. So here's a couple that you may want to try yourself real quickly. On the left here, looks like I've got 2 different sets of points that have the same x value. So again, notice I've got x value of 2 and a y value of 2, x value of 2 and a y value of 5. So if we wrote that as coordinates, we'd have 2, 2 and 2, 5. Same x going to 2 different y values. And this one is actually double not a function because I've got another pair right here that have the same x value. This one is a function. There's nowhere on here that I can draw a vertical line. Okay, no matter where I move that vertical line, it never crosses that graph more than once. So that is a function. So sorry, this is a no, yes, and then we saw this similar example before. Lots of places I could draw a line that would go through twice. So this is not a function.